All right. Please remember that we're working towards being able to use logarithms to solve equations. Some of them that we had already, the variable was in the exponent, but we could get the base the same, so it didn't really matter. Well, now we're going to keep working towards being able to use the logarithms. It's best to keep straight some of the properties, and these are going to be your three main ones you're going to want to know. Okay? Log base b is fine. Whatever base you want to put in there, it doesn't really matter. But basically what it's saying is they have two pieces that it's m times n. So they are multiplied together right here. And what you're allowed to do is if it is under one base, one log base of something, you can split it into two, but only if it's helpful. So if you want to, you can even put numbers in there, because let's face it, for a lot of us, it's easier to see numbers. So maybe if it's log base 2 of, say, we'll go 15. Now, what that's saying is 2 to some power is going to be 15. Do any of us know exactly what that power is? No. But what you used to have to do is go through a bunch of big tables is what they used to have before they had calculators that could solve them all for you. And what it might be helpful to do is to be able to split this into log base 2 of 5 and log base 2 of, that's a 2, of 3. And according to this, do you see, is 5 times 3, isn't that what 15 is? But I split it into two logs. Once you split it, it turns into addition. Have multiplication and addition gone together any time before? Yeah, when we were multiplying bases, what did we do with exponents? We added them. So there's no surprise they go together here. These might be two answers you could find in the table. Maybe you can find log base 2 of 5 and log base 2 of 3 in that table. Then you would add those two decimals together. That would be log base 2 of 15. That's how it used to have to be done. And if need be, we'll go back and do it that way. Okay? Hopefully we don't have to. Okay? But I'll get the tables out. I'll find them. They'll make lots of copies. Hannah? That's a microphone, Hannah. Because I'm recording this right now. Yes. Okay? Since we started. So now, that's obviously called the product property because there's multiplication involved. This one's called the quotient property because it's division. Now, up in the product, did it really matter what order I put things? Because multiplication and addition are commutative. So it didn't matter what order you put it. Here, it is division, so the order is going to make a big difference. Once again, it is log base b, so it means it can be any base of m divided by n. So that's if you have just one log and you want to split it to 2, it becomes log base b of m, log base b of n, and then you do have to subtract. And it is pretty much top minus bottom. Does that make sense how I say that? It's whatever's on top minus whichever one's on the bottom. Again, that depends on the problem you have, but for those of you that might want to see some numbers in there, let's do log base 3 this time of, we could do 2/3 is fine, but not quite what I wanted to have happen, but it'll work out. Maybe that's, let's face it, that's not going to be in those tables, but what will be in those tables is log base 3 of 2 will be in those tables. And I'm hoping you all know this next one. Log base 3 of 3. Because that's saying 3 to what power would give you 3? 1, right? Because let's face it, couldn't we just cross those off and leave the exponent, which would be 1 anyways? So this one, log base 3 of 2 would be in the tables, and then log base 3 of 3 we would know. Okay, so again, this is kind of doing it old school. Now realize you could also go the other way. If you had these two separated, the log base 2 of 5 and the log base 2 of 3, could you put them together as log base 2 of 15 if you wanted to? It works both directions. It depends on which one's going to be most helpful. So those two, very important. This last one also going to save you a lot of time. It's log base b of m to the p. So b stands for base, p stands for power. Right? And all that really happens is this p is allowed, if you want, to go out front. Is really all that happens. This p can go out front, or this p that is out front can go up on the power. When it was a power to a power, what do we do with exponents? Multiply. Do we see another power coming in here? Yeah, and so we are multiplying. It's the same stuff, just a different language. Okay? But it is a language that, yes, there are tables for it, and the calculators can do it quite easily once I show you how to do that, which will be quite a while from now. Would you like a number example of this one? Okay, so let's go, and we can start on the right side or the left side. It doesn't really matter. We'll start over here. So log base, we'll do a different base this time, 4 of 7 to the second. Apparently, maybe that's not very helpful for me. Because do you think log base 4 of 49 is going to be in the table? Probably not. But do you think log base 4 of 7 might be in that table? They're going to do the smaller numbers. And so what you can do is take that 2 that's on the exponent, and where are you allowed to move it? Yeah, it almost seems like it's something you're not supposed to be able to do, but this is what logarithms let you do. The 2 can go up front. So you would find log base 4 of 7 in that table or that chart, and then you would just multiply it by 2. It would give you the answer. Now, remember that prerequisite worksheet we had with the adding decimals, subtracting decimals, multiplying decimals? Yeah, this is why. Because that table is going to give you decimals for all of these answers. So you're going to have to be able to multiply. You're going to have to subtract them, add them. Yeah. And so that's why we spent so much time doing that. So those are the rules. Are there any questions on those? Because now we're going to try to apply. Everybody's good? So what I've done here is I've basically given you one from the table. I told you that log base 3 of 5 is approximately 1.4650. The only reason it's approximate is that decimal goes on forever. And it's saying 3 to that power is 5. Is that believable? Because 3 to the first is 3, right? And 3 to the second is 9. So 3 to about the 1.5 power, does 5 seem possible there? Okay, I'll write it off to the side so you can see it. Because 3 to the first, we know is 3. 3 to the second is 9. My number is 5, right? Is it right here? So 3 to the about 1.5 is believable. Okay? So that actually is correct. And what you'd have to do then is if I gave you a more complicated problem, like log base 3 of 45, is you'd have to break it down. Manipulate it to get it to what you know. And all I'm giving you here is log base 3 of 5. But you also know log base 3 of any of 3's powers. Because we can do the canceling that we did before. So 45, does 45 break down well for me at all? If I were you, I would look for the 5 because that's what we have up here, right? That's the one we know. Does 5 go into 45? 5 times 9. Okay, I'm just going to write it kind of slower here. Right? Is that the same problem? The one I just wrote in red, is that the same as letter A? Is it the same problem? Yeah. And what we're going to do then is having it in one logarithm right now is not helping. And so we're basically, if you want to, you can say we're really breaking it into 2 logarithms. Okay, notice that the base has not changed. Okay. And on one of them, now when we did the product property, did it matter what order things went? Because it was multiplication and addition that went together. Did it really matter? No. So I'm going to put the 5 here. I'm going to put the 9 there. What goes in between them? Addition. Because that product property tells us that it is addition. Of those 2 that we have written down there right now, I'm hoping you know both of them. Obviously, this first one, log base 3 of 5, how would you know that one? Because I gave it to you. Would you know that any other reason, though? Would you know that any other way? Not really. I wouldn't expect you to. Okay, but we know that this completely gets replaced with that. Hannah? Okay, Hannah, you believe you know log base 3 of 9. Is that what you're saying? 2. Okay. Here's why. This is the same thing as log base 3. What do we like to get here if we can? Don't we kind of want to match this number? Can I put a 3 there legally? Yeah. Well, how do you rewrite 9 then so you can put a 3 there? To the second power, right? What I wrote in green right there is the same as the log base 3 of 9. And remember what we've done so far with this when we have this set up? We cancel it, and it leaves it as 2. Some of you may have wondered earlier, how does that 2 just become a number down at the bottom? Because the 2 can actually go up front if we want it to. Okay? So yes, that is 2. Now I'm hoping there is, again, I don't want you using calculators, but I'm really hoping there's no need for a calculator on this one. All right? I hope you can see that it is 3.4650. Here's where this is potentially going to be annoying for some of you, is I do want you to stay away from the calculator. But I also want you to see, does that answer make sense? That's the biggest problem people have. When they go over here to these calculators, they start typing things in. They type one number in wrong. It gives them a bizarre answer, but they write it down anyways because they have no clue what they're doing. So let's see. What this is saying is that 3 to this power is going to give me 45. Is that believable? Because 3 to the third is 27. 3 to the fourth is 81. So do you agree 3.46 is somewhere in between these two exponents? So is it believable that the answer is somewhere between 27 and 81? And does 45 fit into that mold? It does. So this is where I have problems. When people type this into a calculator, they get the answer of 5.46 or something like that, and they don't realize that 5.46 can't possibly be the answer to that problem. Or they get 1 point something. There's no way that can be the answer to that problem. So let's take an educated guess on this next one. It's basically saying 3 to some power has to be 25. Do we know that one off the top of our head? Is that one of them on our little sheet we had the first day of notes? But one's really close. Because 3 to the third is 27. So is the answer to letter B going to be bigger than 3 or less? Because here's the exponent. By a lot? No. So what do you want to guess? Maybe 2.8, 2.9. Okay. All very good guesses. So let's take a look. I'm going to have to erase a little bit here. Well, this is not one we know, but we do know log base 3 of 5. There's actually 2 ways this can be done. Hannah? Okay. So 25 is 5 times 5. So what I just wrote in blue is the same thing as letter B. And the reason we would write it that way is now I can break it down because it is multiplication. Once again, notice the base hasn't changed when you do that. The reason I'm going to try and break it up is the way it's sitting right now is not really helping. And so what should I write here on this log base 3? 5, and then over here, and then in between, plus. And now log base 3 of 5, we just look up here. It is 1.4650 plus 1.4650. And somebody just said times 2. Would that work if you took 1.4650 times 2? Yeah, it would end up the same way. And I'll show you why it would end up the same way in a second. But if you need to, you can just write them right underneath each other. Line up your decimals, of course. 0 plus 0 is 0. 5 and 5 is 10. Carry the 1. Did that come out to about where we were guessing? Little less than 3. Very believable. Had you gotten 1.93 or 0.93 because you did some arithmetic wrong, I hope that you look at that and say that can't possibly be right. Because yes, it would take you about 2 seconds to type this into a calculator if I refreshed your memory on how to do it. But I need you to know what's actually happening. Trust me, it's going to save you a lot in the long run. Everybody got that down? The reason times 2 actually worked right there is because you could have written it as log base 3 of 5 squared. Where can that 2 go if you want it to? Out front. So then it's 2 times whatever log base 3 of 5 is, and log base 3 of 5 is 1.465. So isn't it just 2 times that? It's the same thing. Either way it works. So any questions on A or B? All right. What do we got? Ooh, well, I've given you 2 from the table this time. We've got log base 4 of 5 and log base 4 of 15. Are both of those believable? So 4 to that power would be 5. 4 to this power would be 15. Why is that one believable? 4 to the second is 16, so 4 to the just short of 2 should be 50. So very believable. So how are we going to do log base 4 of 5 over 16? Can I do it as it's written right now? No, so we've got to, it's in one log and I can't do it, so we got to try 2. Am I going to change the base as we go? No. So there's going to be a log base 4 there. I'm going to split it into 2 logarithms. Now, when we did that last two problems, the order didn't matter. Well, when you divide things, does order matter? Yeah. So same thing with the subtraction that goes with it. And so which one should come first? Log base 4 of 5, and then log base 4 of 16, and you subtract. Okay. Now, you might think that it was a typo up here that I gave you log base 4 of 15, but it was not a typo. Okay. Because, again, I'm hoping you can tell me both of these. It's saying 4 to what power gives you 5? Well, that's up here, right? It's written right there. 1.1610 minus. Why is it minus 2, Miss Paith? Exactly. This could be written as log base 4 of 4 to the second. Whenever possible, if you can get those bases the same, do it. And they do cancel to give you 2. And this, I believe, is the one that a lot of you had a whole lot of fun on when I made you do it about a week ago. Remember when I gave you a decimal and the smaller one was the bigger of the two numbers? Who remembers how to do it now? Again, by hand, right? Yeah, exactly. You got to go 2 and then add some decimals in there. And you have to subtract the other one. And your job is to remember that this answer is going to be positive or negative. It's going to be negative. Okay? And so we got 0 minus 0. We're good. There's 0 minus 1. You can't do that. So you have to borrow. So it becomes a 1, then a 9, then a 9, then a 1, 10, basically. So 10 minus 1 is 9 minus 6. 9 minus 1. 1 minus 1, 0. Is that the answer? 0.8390. No, it's negative. Very good. Remember, negative makes it unhappy. So it's basically going to take that 4 as the power, make it a little unhappy. That's believable. Because negative exponents are going to make these numbers smaller. Okay, so it is believable. Okay? D almost seems like it has to be a typo. Log base 4 of 3. Well, let's take a guess again, though. More than 1 or less than 1? Why is it got to be less than 1? Yeah, 4 to the first power would be 4. So this has to be less than 1. Is this going to be a negative? No. It's once you get to fractions. Any way that we can get log base 4 of 3 out of this, Sarah? Okay, very good. What Sarah said, if you didn't hear it, is she said, well, let's rewrite it as basically log base 4 of 15 over 5. Is 15 over 5 3? Okay, and this is kind of how you'd probably possibly have to do this one because of the tables, the way they worked. Okay, so now that we do this, log base 4 of 15 here, log base 4 of 5 over there, minus. So now you can see why I gave you log base 4 of 15. Now I made the worksheet. Is there any guarantee that you're going to use every one I gave you from the tables? No. There's no guarantee, but most times you probably will. So it's 1.9534 minus 1.1610. Do we have to do that, switch things around like we did on C over here, and remember it's negative? No, the bigger one's in front this time, so we don't really have to worry about that. So we can put the 1.1610 down there. And it is minus, so 4 minus 0 is 4. 3 minus 1 is 2. Uh-oh. Got to borrow. I know. 9. Is this one negative? Now, does this fall into what we were believing? A little less than 1, right? So that's very believable. Are you starting to understand what I mean that I want you to be able to look at these and know if they're right? Or know if they even have a chance? I'm hoping anything like 2 point something on this letter D, you would have known it was wrong. Okay. Are there a lot of students out there that just type these into a calculator and don't know that? Yeah, there's a ton of them. Okay. Any questions? All right, here we go. Helpful hints when solving equations with multiple logarithms. Suggestion number 1, get everything in a logarithm. You've noticed a few things lately that weren't in logarithms, so we're going to have to work on that. this is an experiment, because from now on, if I can record every day, I can put it on the internet. Because it's recording in real time with what I'm doing here.
Wait, so everybody could go online and listen to your voice?
If I put it online, and it shows what I'm writing in real time, yes. But I have a feeling that this file is going to be relatively large.
Like
This particular file, when I'm done with it, is going to be pretty big, I bet. Suggestion 2 is only one logarithm on each side. Because once you only have one on each side, what have you been allowed to do earlier in this chapter? When you have just one on each side, you got to cross them off. Did I? Oh yeah, there's a little T in there. Extra T. Yeah.
See, I went back and just switched it thinking it was right.
It's logarithm.
Yeah, I think it looks
Any questions on your 2 suggestions? I suggest them in that order as well.
wait.
Okay, again, this is with multiple logarithms. Do we have multiple logarithms? Yes. Actually, it looks quite complicated. Please realize that actually these first 2 things, 2 log base 3 of 6 minus 1/4 log base 3 of 16, those are just 2 numbers written in really strange forms. Again, another language is all it is. So now, suggestion 1, everything in a logarithm. So as you look at 2 times log base 3 of 6, and that term is everything in the logarithm. No, the 2 is actually out front of the logarithm, correct? So it's not in. So that 2 has to be moved inside the logarithm. And how do you do that? Yeah, you make it a power of the 6. So this is really saying log base 3 of what, technically? 36, right? Minus. Notice how I didn't worry about the minus. But I am going to worry about the 1/4. That 1/4 times the log base 3 of 16, that 1/4 is not in the logarithm. So we do have to move that one as well. So it's log base 3. Now, 16 to the 1/4. What does 1/4 power mean again? 16 radical 1/4, right? Like that. So it's the 4th root of 16. 4th root of 16 is 2. Remember, you could do it this way. 4th root of 2 to the 4th, correct? That's what we did earlier in Housify. So 16 to the 1/4 can be rewritten as log base 3 of 2. It's the same thing. How about this log base 3 of x? For that term is everything where it's supposed to be. Yes, it's in the logarithm. We're good. So suggestion 1 that I gave you, have we accomplished that? Okay, so suggestion 2 then says to have 1 log on each side. Unfortunately, on the left side, I have 2 of them. Some people have given good suggestion before. Let's add the log base 3 of 2 over to the other side. Then you only have 1 log on the left side. But then I have 2 on the right side. Okay, great. Exactly. Let's put the first 2 together. So far, we've been ripping these logarithms apart. Let's throw them back together. Okay. So they are both log base 3, so we can do that. But this subtraction is going to turn into, just kind of think of the subtraction as getting bigger. It turns into a division button. And you have to watch which way you write it, though. Is it 36 over 2 or 2 over 36? Yeah, the first one goes on top, and then the second one goes on the bottom. Again, the order is huge when it's division and subtraction. And then that's supposed to equal log base 3 of x. So that was Ray's suggestion. Do you believe that was a good suggestion? That was excellent, because now we have 1 log on each side. The reason it's good, exactly, like Brandy just said, let's cross them off now. Because this log base 3 doesn't have any bearing on the variable anymore. No, it's the same on both sides. And so in this problem, all you have to do then is figure out what 36 divided by 2 is. 18. Of course, you should plug it back in to make sure it doesn't cause any problems. The only place I would be substituting 18 back in is right there. Is that going to cause any problems? No. Now, did you really necessarily solve for exponents here? No. You use logarithms to figure out what x value would make this equation true. And I believe this is our last example for today. Oh, we have two more? The other one's pretty simple, though. All right. Suggestion 1. Everything in a logarithm. How about that first term, log base 10 of z? Is that a problem? No. How about log base 10 of z plus 3?
Yep.
Is that a problem? No, that's fine. The parentheses are saying the z plus 3 is all in there. The 1 has a huge problem. There's no log there at all. Now, there's certain numbers that you can write a lot of ways. 1, I hope you know by now, is one of them. That you can write a lot of ways. Remember all the funny form of 1 that we've had. But in this problem, I need a logarithm over there, and the base has to be what, according to this problem? The base better be 10. Now, if I had a different problem, could the base be something different? Yeah, it depends on the problem. But here, I need it to say, now remember, I'm only messing with one term, so can I change the value of 1? I can't change the value. I have to change the appearance or the form of it. Okay? Nope, not log base 10 is 0. Log base 10 of Morgan? 10. Because is log base 10 of 10 to the first, is that 1? It is. So what if the base was 8? You do log base 8 of 8 to the first, right? That's how it would work. And so now we're at least, we have taken care of step 1. Everything is now in a logarithm. Now, some of you are looking at that right side and you want to cross that log base 10 and the 10. But then you're right back to where we started. So just hang on. We are going to cross the log base 10, but we're going to do it to the most of our advantage here. So we did step 1. Step 2 is to get only one log on each side. And so we got to take a look. How are we going to do that? Sarah? Exactly. These two can be put together. Again, we've been ripping it apart all up until now. Now we're going to put them back together. So it is log base 10, and there is a z, and then this addition is going to turn into multiplication. But be careful how you write it. Okay. So step 1, did we get everything in a log? Yeah, we did. It was pretty tricky. Now, we got one log on each side now. Now we've done step 1 and 2. If you do those 2 steps properly, you should get to this point where you can do what? Yeah, you can get rid of the logarithms. And let's face it, that gets this problem back to what much more used to looking at. Okay. And we get z squared plus 3z equaling 10. So you're saying this problem equaled 1 before and now it equals 10? It does because we changed the problem. We might have to. Yeah, I see a quadratic term there, z squared. I see a linear term, 3z, and a constant term, 10. But when doing quadratic, of course, you want it to equal 0. So this 10, we have to subtract over to the other side. Now, you do always have the option of key number, but is key number guaranteed to work? No. But what is guaranteed is quadratic formula. But I think I heard somebody come up with the key numbers over there. Because it has to multiply to be -10 and add to be 3. Do such numbers exist? They are 5 and -2. I'm going to go the longer method here. There is kind of a shortcut on this one, but I think some of you need a review. Z squared, this one gets split. 5z minus 2z minus 10. Don't worry, it still equals 0. What's our reason for going to 4 terms? We had 3. Why go more? Yeah, now you can put the squiggle in. Make sure you take the sign with the second half. So what can I take out of that first portion? Z, what remains in there then? Z plus 5, right? So I have to have z plus 5 on the right side. Is there a z plus 5 over here? It's kind of hard to see it, but it is there. What do you have to take out of this half? -2. So your factors are z minus 2, z plus 5. It is supposed to equal 0. So you set each one equal to 0 because it is multiplication in between there. And z has to equal 2. Z has to equal -5. Well, for those of you that have learned the shortcut when there's a 1 out front, if you just want to find the zeros, you do just switch the signs of your key numbers. If you want the zeros. Yeah, I haven't circled them yet, have I? You put 2 in, log base 10 of 2 plus log base 10 of 5. Is it believable that that's 1? It's believable. I can prove it to you in a second, but I'm not going to do it right now. Because let's put -5 in. Log base 10 of -5. Yeah, not going to happen. Now, once again, how come this quadratic and this key number keeps giving us these wrong answers from time to time? Exactly. This quadratic right here has no clue what problem I'm actually trying to solve. That's a parabola that apparently hits the x-axis twice. That's all it knows. Our job is to figure it out. Now, for those of you that want to see it, this unfortunately won't get recorded, but that's fine. Log base 10 of, what was the other answer, 2? Plus log base 10 of, if you put 2 in, you get 5. It's supposed to equal 1. Put these two together. It's log base 10 of 10. Is that going to equal 1? Yeah, you can write it down. That's fine. I'm not going to erase it. It's just it won't get recorded. Unfortunately, you can't record the whiteboard. So now, we'll do that. Any questions? Letter C is for you to finish for tomorrow.
So when you're talking,
Worth, oh, I don't know, 20 points. Miss Piper, you have a question?
so when you're talking to us right now, it's
Yes, it is.
so
It records until I turn it off, Miss Piper. No. Kenzie. Probably.